Stanzin Lamo, what topic we were discussing in the last class? I think you were present in the last class, right? What was the
Yes,
topic that
sir.
we were dealing with? What was the topic that we were
El-
dealing with in the last class?
electric flux, sir.
Okay, electric flux. Okay, so I'll start that. I'll discuss the definition of electric flux once again, and then we'll discuss few more things related to that electric flux. तो मैंने आपसे ये बोला था कि what is electric flux? So I told you electric flux is basically the field lines crossing through a surface placed inside an electric field. And crossing through a surface placed inside an electric field, that is basically called as electric flux. Means what? For example, say in this region, this are the field lines representing the electric field is existing in this region. इस region में exist करने वाला electric field is represented by these field lines. So undoubtedly I can say that if few of the field lines is passing through the surface. Of course, few of the field lines is passing through this surface. So the number of field lines which passes or crosses a surface held inside an electric field is basically called as flux. Means what? In simple, I can simply say that if you place a surface inside an electric field, so some electric field will pass through that surface also, and the field that is passing through the surface will be simply considered as electric flux. So this is basically the definition for electric flux. Now, next point is how to calculate this value of electric flux. Electric flux हम कैसे calculate करेंगे, है ना? This is I know that if some surface is placed inside an electric field, of course there will be some field passing through that surface also. Okay, for example, if rain is falling vertically downwards, if rain is falling like this, and I place a surface somewhere here, so some water will also pass through this surface, right? In the similar way, if there exists electric field in the region, and I place a surface in that region, so some of the field would be crossing this region also. So this field which is crossing the region will constitute electric flux, right? Now the point is how we will calculate the value of this flux, how we will calculate this electric flux. So see the formula. What is this formula? Sir, let me assume that this is a surface. This is a surface which is kept inside an electric field, a region in which there exists some electric field, and electric field is like this. Let's say, for example, I'm making another surface. Let's say the surface is like this, right? The surface is placed like this. This is a surface. And your electric field lines are passing through the surface like this. This is the direction of electric field, and the surface is placed somewhat inclined to the surface. Try to understand this. Okay, electric field is going in the horizontal direction, and surface is placed somewhat inclined. Did you understand the meaning,
Yes,
everyone?
sir.
I'll show you by just switching on my video. I think you can see me now. See this. This surface is not like this. This surface is somewhat inclined. This surface is inclined by some angle, right? This is the surface. And your electric field is like this. This is the direction of electric field. This you can see. This pin you can see in my hand. It is in the x-axis, and this surface is inclined at some angle, right? So this is the surface which is inclined at some angle, and we have the electric field in the horizontal direction. Then how we are going to write the value of the flux in this case? Okay, how we are going to write the value of flux in this case, or what is the formula to calculate the flux? So ये surface है आपका, and this is your electric field. So first of all, let me draw the normal to this surface. Can anybody tell me how the normal to the surface will be drawn in this case? Can you tell me? How do you think the normal to this surface will be drawn? If this is a surface, normal means what? Perpendicular to this surface, right? If this surface would have been like this, normal would have been like this, right? Tell me yes or no. ऐसे होता ना
Yes.
नॉर्मल. लेकिन अगर ये सरफेस ऐसा है तो नॉर्मल कुछ ऐसा आएगा ना, देखो नॉर्मल कुछ
Yes.
ऐसा आएगा. ठीक है, दिस विल बी द डायरेक्शन ऑफ नॉर्मल एंड इट विल नॉट बी इन द हॉरिजॉन्टल डायरेक्शन, इट विल बी एट सम एंगल with the electric field, right? So this will be the direction of normal, or you can say this will be the direction of area vector, and the angle between these two is theta. The angle between these two means what? The angle between theta is angle between electric field vector and area vector. The angle between them is theta. So in this case, the flux is defined as E multiplied by A multiplied by cos theta, where E is the magnitude of electric field, A is the area of that surface, and theta is the angle between the electric field and the area, electric field and the area. This flux can also be written as E dot A. So do you remember? I told you in some previous classes, area is a vector quantity. If area is a vector quantity, you may have seen this type of result in class 11th in the chapter of vectors. And if you remember, in vectors, you must have studied something called as dot product. Do you remember that? In
Yes,
vectors,
sir.
you have studied this topic, which is dot product. And the dot product of two vector is written as AB cos theta, where A is the magnitude of one vector, B is the magnitude of another vector, and theta is angle between the two vector. Similarly, if you see electric field is a vector, area is a vector, and theta is the angle between them. So this can also be written as E dot A. In other way, we can simply say that flux is the dot product of two vectors. One is electric field vector and another one is area vector. मतलब मैं ऐसे भी कह सकता हूँ कि flux is dot product of electric field vector and area vector. So can anybody tell me, if the flux is the dot product of two vector, one is electric field and another one is area, can you tell me what kind of quantity will the flux be? Means whether the flux will be a scalar quantity or vector quantity. What do you say? What type of
Scalar
quantity the flux
quantity.
will be? Of course, it will be a scalar quantity. Why? Because the dot product of two vector is always a scalar. So this quantity will be a scalar quantity. This is a scalar quantity. This quantity will be a scalar quantity, right? Okay, and what will be the its SI unit? Who will tell me the SI unit for this? SI unit. So undoubtedly we know that SI unit for electric field is Newton per coulomb, and for area it is meter squared. So I can write this as Newton meter square per coulomb. Is it clear? Newton meter square per coulomb. This is the SI unit for electric flux, right? अब देखो कुछ और बातें सुनो. Listen to some more points related to this. Sir, if I tell you that this is a surface, this is a surface, this is the direction of electric field, and obviously this will be the direction of area vector. Tell me yes or no. Sir, if surface is placed like this, I will show you again. Sir, what I'm saying is, if surface is like this, can you see me? Surface is
Yes,
like
sir.
this. So normal to this is in the horizontal direction, and I am saying electric field is also in the horizontal direction. So what
Yes,
will
sir.
be the angle between A and E? Who will tell me? What is the angle between A and B? A and E. What is the angle between A and E?
0.
Of course, it is 0. What about others? Obviously, the angle between A and B will be 0 without any doubt, right? So if the angle between them is 0, here the theta is equal to 0 degree. So what will be the value of flux? Flux will be equal to EA cos
Okay.
0. है ना? तो flux will be simply equal to E multiplied by A. This is the maximum flux that can flow. In this case, the flux through the surface would be maximum. Did you understand? The maximum number of field lines that can flow through the surface is when the area vector and electric field vector are in the same direction. अगर area vector or electric field vector, if both are in the same direction, then in that case maximum field lines will flow through the surface. Is it clear?
Yes, sir.
नोट करो इसको जल्दी से, नोट इट फास्ट. Note it fast, please. Can I erase? Did you note?
Yes, sir.
Okay, so moving on. See, the first case I've already shown you if electric field vector and area vector are in the same direction, in that case the maximum possible flux will flow through that surface. Okay, now I'm taking another case. Say if this surface is like this, it is placed horizontally. This surface is placed horizontally, right? Means what? I'm showing you again on the switching on my video. See, if you can see me, please say this is the surface like this. In which direction do you think the normal will lie? What will be the direction of normal?
Upward.
Upward. This will be the direction of normal to this surface, right? This will be the
Yes.
direction. No. So if this is the direction of normal, which is vertically upwards, if the direction of normal is vertically upward like this is the direction of normal, that is area vector. Either I call it as normal or area vector has the same meaning. And let's say the electric field in this case is like this. Electric field is in this direction, the normal or the area vector is in this direction. If I ask you what is the angle between them, the angle between them will obviously be equal to 90 degree. The angle is 90 degree. And if the angle is 90 degree, what will be the value of flux? Flux will be equal to EA cos 90. In this case, the flux flowing through the surface will exactly be equal to 0. Did you understand?
Yes, sir.
Similarly, if I say for a surface, if I take normal to this surface, let me say if the normal to this surface is in this direction and the area vector or sorry, electric field vector is in the opposite direction to that of area vector, means if the angle between them is 180 degree, that is if electric field and area both are opposite to each other, then in that case angle will be 180. So flux will be written as EA cos 180 degree. So flux will be equal to minus of EA. This will be the negative value of flux. Wherever you get flux negative, negative flux will mean that the area vector and electric field vector are not in the same direction. Negative flux simply tells you that the area vector and electric field vector are not in the same direction, rather they are opposite to each other. Clear? Please note it fast. Can I erase this, beta?
Yes, sir.
Okay. So these are the formulas. Before I start some other concept, I would like you to solve one or two basic questions based on this. But to solve that basic question, you will first have to solve, or you will first have to tell me, do you know how to take the dot product of two vector? For example, let me say if I write a vector as 2i cap plus of 4j cap, let me say that. And I write vector B as, let's say I write it as 4i cap plus of something 2j cap, let's say. So how do we find dot product? Do you remember that? Please tell me. It is not the it is not the duty of only one student to respond. I can see other also. I cannot pronounce this name, but I can pronounce the last name Galdan, I guess. Chiang Galdan. And the third one is the Stanzin Lamo. Do you know how to take the dot product of two vector? Tell me fast.
Yes, sir.
Nilza, you know. And what about Galdan and Stanzin? Stanzin, do you know how
Yes,
to
sir.
take the dot product? And Galdan, I cannot pronounce the name. You can see your name yourself. This, I'm asking this student. I'm asking you to unmute. Tell me, do you know how to take the dot product? Chiang Galdan. I don't know. This student is not responding. Anyways, I'll tell you how to take the dot product. Then I'll give you question based on flux. First, try to understand. Sir, how to take the dot product? First, write it as 2i cap plus 4j cap dot 4i cap plus of 2j cap. You just have to remember two things: I dot I or k dot k or j dot j is always equal to 1. Okay? Whereas I dot k equal to k dot I is equal to 0. I dot j equal to j dot I is also equal to 0. And j dot k equal to k dot j is also equal to 0. You just have to remember this. ठीक है? क्यों 0 हो रहा है यहाँ पर और यहाँ पर 1 क्यों हो रहा है? Because if you take I dot I means both are the vector along x axis, that is theta is equal to 0 degree. When theta will be 0, cos 0 will be equal to 1, and hence the dot product is 1. समझ रहे हो? But if you have I dot j means one is along x axis, another one is along y axis. One is along x, another one is along y, because I means x axis, j means y axis, right? Here theta will be equal to 90 degree and cos 90 degree is how much? So cos 90 is equal to 0. That is why I dot j or k dot I or whatever, where the angle between the two is 90 degree, the result will be 0. And when the angle is 0, the result will be 1 for the product of unit vector. Is it clear? Now moving on. See, can I write this as A dot B? See this, 2i cap, 4i cap. Can I write 8i dot I? Sir, kuch to bolo.
Yes, sir.
I multiplied 2 by 4. It became 8. I dot I plus of again I'll multiply 2 by 2. So it will become 4. I dot j. Now we have already multiplied with I. Now I am going to multiply these two terms by this 4j. So if I do that, this will become 16j dot I and this will become 8j dot j. Who will tell me now what is this I dot I? What is this I dot I? Tell me fast.
1.
I dot I is 1. So 8 into 1 is 8 plus I dot j is what?
0.
0.
0. J dot I is
0.
0 plus j dot j is 1.
1.
So A dot B is what? A dot B is equal to 16. This is how
16.
you will take the dot product. Did you understand how to take the dot product? Because you need to know this, because I will be giving a question based on this concept of dot product and I relate it with flux. Okay, so you should know how to take the dot product. Please note it fast so that we can go to the question based on flux. Done. Roll number 48. What's your name? Roll number 48. What's your name? Roll number 48. What's your name?
तबस्सुम सर.
अच्छा तबस्सुम. आज डिफरेंट नेम से आई हैं आप. Anyways, so I am erasing this. Now I am asking you question based on flux. Very basic question. Don't get confused. You don't have to be afraid of the question. Try to understand what I am asking. Question is, in a region of space, an electric field exists which is represented by E is equal to 4I cap plus 2J cap plus 6K cap. This is the value of electric field. What does it mean? Electric field is along x-axis, y-axis, z-axis, or along all the three axes. What do you mean by this? If I say electric field is 4I cap plus 2J cap plus 6K cap, what does it mean?
It is
Is it
along
only
all the
along
all the three axes.
all the three axes, right? It is spread over the whole space, whole volume, right? Now, calculate electric flux through a surface, through a planar surface, let's say, of area 20 centimeter square. Take care of the unit. I have given area in centimeter square, but it is not the SI unit, right? Area of centimeter square if the surface is kept in पहला XY plane, दूसरा XZ plane, तीसरा YZ plane. First you note down the question, then I'll explain you the question. First you note down the statement of this question, then I'll explain it and then we will solve. नोट कर लिया क्वेश्चन बेटा? नोट करके मुझे बताना ताकि मैं सॉल्व करूं.
Yes, sir.
ओके, तो अगर आपने नोट कर लिया तो ट्राई टू अंडरस्टैंड व्हाट आई एम आस्किंग इन द क्वेश्चन. आई विल इरेज एवरीथिंग. सी, आपसे कहता है कि कोई एक सरफेस है, देयर इज अ सरफेस एंड फर्स्ट वी हैव केप्ट दिस सरफेस इन XY plane. Means what? This is your x-axis, this is your y-axis, this is your z-axis. So surface is placed like this. This is your surface. Say this is your surface and this is placed in XY plane. Can anybody tell me if the surface is placed in XY plane, in which direction do you think its area vector will point? Or the normal की direction क्या होगी? In which direction do you think the normal will be pointing? अगर मैं किसी सरफेस को XY प्लेन में रख रहा हूं तो उसके नॉर्मल की डायरेक्शन क्या होगी? एरिया वेक्टर की डायरेक्शन क्या होगी? व्हाट विल बी द डायरेक्शन? सी, दिस इज अ सरफेस, इट इज प्लेस्ड इन XY प्लेन. तो व्हाट विल बी द direction of the normal to this surface?
Z.
Sir, obviously that will be Z. By which axis is perpendicular to X and Y? Of course Z. See, surface कहाँ रखा है आपने? Surface is placed in XY plane. So the axis which will be perpendicular to this will be Z only, ना? Sir, बोलो तो.
Yes, sir.
Sir, है ना, वो axis which is perpendicular to both X and Y, that will be Z. Simple सा point है ये. इसका मतलब है कि this will be the direction of area vector. Area vector will be along Z axis. Area vector is along Z axis. और एरिया की वैल्यू कितनी गिवन है? 20 सेंटीमीटर स्क्वायर. तो एरिया वेक्टर क्या होगा? देखो, एरिया वेक्टर विल बी इक्वल टू 20 सेंटीमीटर स्क्वायर के कैप. डिड यू अंडरस्टैंड व्हाई डिड आई राइट के कैप? और
Yes, sir.
एरिया वेक्टर आई कैन राइट इट एज 0.2 के कैप इन मीटर स्क्वायर. सर, टेल मी यस और नो.
Yes, sir.
Why I am writing k cap? K represents z axis. That is why I am writing k cap. है ना? अब
Yes.
फ्लक्स क्या होता है? फ्लक्स इज E डॉट A.
A.
नाउ टेल मी व्हाट इज द वैल्यू ऑफ E. E की वैल्यू बता दो. क्या लिखा था मैंने? आई जस्ट फॉरगॉट.
4I cap
यस,
plus 2J cap
वेरी गुड.
plus
एंड द
6K
लास्ट.
cap.
Okay, I have to take the dot product of this whole with this 0.2 k cap. Who will tell me what is I dot k?
0.
J dot k?
0.
And what is k dot k?
1.
So flux will be simply written as 6 multiplied by 0.2 is 1.2 and k dot k is 1. So this is the value of flux.
Yes, sir.
This is the first case. What is the next case? What is the second case? In which plane have you placed that surface?
XZ.
XZ. See, if this is your x axis, y axis and z axis, x, y, z, means you have placed the surface like this. Like this. This is the surface. In which direction do you think its area vector will point?
XY.
Y. है ना? अगर मैं ये बात समझो, मैं I am going to switch on my video again and will show you here. See, if this is the surface, this is obviously placed in XZ. So obviously if you drop a perpendicular, which is called as normal, perpendicular का ही दूसरा नाम normal है. तो अगर आप इस पे perpendicular drop करोगे तो that will obviously be along y axis or not. This is the perpendicular. Clear है?
Yes, sir.
इसका मतलब if the surface is placed in YZ plane, so its area vector will be along y axis. This is the direction of area vector. So in this case, I can write area as 0.2 J cap. Did you understand?
Yes,
So
sir.
flux will be written as E dot I, that is 4I cap plus 2J cap plus 6K cap dot of 0.2 J cap. Now what will be the value of flux? See, I dot J will become 0, K dot J will become 0. So this will be equal to 0.4.
Yes, sir.
Only this and this when multiplied will have a non-zero value. I think आपको समझ में आ रहा है. Hurry up. We'll take the last case now. Done.
Yes, sir.
Okay, what is the last case? This surface is placed where? Obviously
Between
the
Y
surface
and
YZ, Y and Z. So what do you think will be the direction of area vector in that case? If you
X
play, obviously
I
very
cap.
good, because the third axis will be the area vector. I'm showing you by drawing it here. if say this is your x-axis, y-axis, and this is your z-axis, and if you place a surface somewhere here, if you place a surface somewhere here, ऐसे रख दो आप किसी भी surface को ऐसे, this is a surface, so obviously the perpendicular taken will be obviously along x-axis. This will be the direction of perpendicular, or you can say this will be the direction of area vector. So in this case, area vector will be written as 0.2 I cap. ठीक है, तो अब आप फ्लक्स लिखो फिर से, फ्लक्स की वैल्यू 4 I cap प्लस ऑफ 2 J cap प्लस ऑफ 6 K cap डॉट 0.2 I cap. Undoubtedly K dot I will be 0, J dot I will be 0, so flux will be equal to 0.8. Am I correct?
Yes, sir.
Okay, note this fast so that we can proceed. चलो आगे बात करते हैं, आपने नोट कर लिया होगा आई गेस, तो लेट्स डिस्कस सम मोर पॉइंट्स रिलेटेड टू द फ्लक्स. देखो अगर ये तो एक प्लेन सरफेस था ना, दिस वाज ओपन सरफेस, और यू कैन से दिस वाज ओनली अ प्लेन सरफेस और ओपन सरफेस, दिस वाज द सरफेस, लाइक दिस इज द सरफेस, है ना, तो ये सरफेस था. अब अगर सर मैं इसी केस में अगर मैं कोई ऐसा सरफेस ले लूं विच इज क्लोज फ्रॉम ऑल द साइड्स, मतलब थ्री डायमेंशनल सरफेसेस, फॉर एग्जांपल लेट्स से इफ आई टेक अ सिलेंडर or I take a cube, these kind of surfaces which is in more than one plane, means a closed surface which has some volume, right? If I take these kind of surfaces, then how we will calculate the flux? Try to understand. Say for example, if I take this surface, this cylindrical surface, means I have taken a cylinder and this is the direction of electric field. Let's say this is the direction of electric field. Then in this case, how will you find the value of flux? Because this cylinder is not a single surface. Okay? This is a closed surface. Why I'm saying how will you calculate the flux in this case? Because if you see, so this is also a surface in this case. This is also a surface in this case. And if I draw the normal to this surface, it will be outward. It will be outward, but towards negative x-axis. And for this surface, which is curved surface, if you take the normal, this will be outward along the y-axis. The direction of this normal will be outward, but along y-axis. Is it clear or not? Tell me yes or no. Are you getting what I'm saying?
Yes, sir.
Let's say the radius of this circular part is r and the length of this cylinder is L. Let's say. So in this case, how will you find the flux? Because the direction of area vector in different segment is different. See, if you had only a single surface, the direction of area vector was either this or the direction of area vector was that. तो कोई एक ही डायरेक्शन थी ना एरिया वेक्टर की, आप कोई एक ही डायरेक्शन कंसीडर करते हो ना एरिया वेक्टर की, बट यहां पर तो सर एक से ज्यादा डायरेक्शन दिखाई दे रही है हमें एरिया वेक्टर की. वी कैन सी द डायरेक्शन ऑफ एरिया वेक्टर इन मोर देन वन डायरेक्शंस. तो अब कैसे करें? तो इफ यू हैव दीज काइंड ऑफ केसेस, तो आप क्या करेंगे, एज मेनी एज सरफेसेस आर देयर, यू विल check the flux for all those surfaces individually. पता नहीं क्या बोले. Sir, tell me, cylinder is the combination of how many surfaces which you can see from this diagram? How many area vector or how many direction of area vector you are observing in this diagram? Sir, one is this, another one is this, and the third one is this. How many directions can you see here?
3.
भाई सबको समझ में आ रहा है? Obviously there are three directions of area vector. For this right surface, the area vector is towards right. For the left surface, area vector is towards left. And for the curved surface, area vector is towards y-axis. तो आप क्या करेंगे इस केस में? Let me call this as surface 1. Let me call this as surface 2 and let me call this as surface 3. आप क्या करेंगे मैं बताता हूं. आप पहले consider this as individual surface and calculate the flux. तो अगर आप फर्स्ट सरफेस पे फ्लक्स निकालोगे तो देखो इलेक्ट्रिक फील्ड और एरिया वेक्टर फर्स्ट सरफेस पे दोनों सेम डायरेक्शन में है या नहीं है.
Yes, sir.
मतलब मैं ऐसे लिख सकता हूं E मल्टीप्लाइड बाय एरिया मल्टीप्लाइड बाय cos 0 डिग्री.
Yes.
And if you see this surface, it's a circular surface, right? In a cylinder, these two are the circles, right?
Yes.
And this is having a radius of r. So can I write this as E into pi r square? I have given you the radius. है ना?
Yes, sir. Yes.
Similarly, for the surface number 2, see this. Surface number 2, electric field तो right की direction में है, but area vector is towards left. See this. E a cos 180 लिखूंगा या नहीं? Should I write this
No.
as E a cos 180? Because for this surface,
Yes, yes.
theta is equal to 180 degree. So you will write it as minus E into pi r square. Minus E into pi r square. This is the value of flux for the second surface. Clear है?
Yes.
Now tell me from your uh, wisdom, just tell me what will be the value of flux for this curved surface.
0.
जिसको मैंने थर्ड कहा. Very good.
0
Why will it be 0?
Because it
cos
will be
90
90 0.
Angle is 90 degree, है ना? Because normal is pointing in the y direction and the electric field for this surface also it is in x direction. So I will write this as EA cos of 90 degree and this will be equal to 0. So what finally we will do, we will write net flux as sum of all the fluxes phi 1, phi 2, phi 3, and we can add them easily because this flux is a scalar quantity, it's not a vector quantity. So we will write this as E pi r square plus of minus E pi r square plus of the third one is 0. The whole result that you will get will also be 0 in this case,
0.
because this and this will cancel out. Did you understand? If you have the combination of different type of surfaces, then the method is to calculate the flux for each individual surface. क्या करोगे आप? You will calculate the flux for individual surface and then you will add the all the fluxes. तो पहले इसको please आप note कर लो so that I can proceed with the next example. Done, sir?
Yes, sir.
Okay, so let's move. I'm giving you one example which you will attempt first and then I'll solve. बिल्कुल similar question. I'm just changing the orientation of the cylinder. Let's say I'm placing the cylinder like this. I have placed the cylinder vertically. I have placed the cylinder vertically. Radius of its circular part is R. The length of the cylinder or the height is L, right? Electric field in this region is like this, towards right. This is the direction of electric field. You just have to calculate the net flux. Try to solve. Try to solve first and then I'll tell you how to solve. ठीक है? You try first, then I'll give you the result for this. Okay, sir, are you done with the problem? Could you solve this? What happened? No response from your side. Are you still solving or what? The excess, what is exercise E3.1? चलो देख लेते हैं. Okay, I've got an answer, but let me solve it. See, for this upper surface, if you can see, oh, if you can see this upper surface, for this upper surface, don't you think the normal to this surface will lie in this direction? Tell me yes or no, please. And
Yes.
about, if you see the lower surface, the normal to this surface, normal मतलब perpendicular, और perpendicular भी कैसा? Outward. It should not be pointing into the body, it should be pointing out of the body, right? अब अगर मुझे एक बात बताओ, what is the angle here between the electric field and this area vector? What is the angle here?
90 degree.
90 degree. So if the theta is equal to 90 degree, who will tell me what is will be the value of flux here, beta?
0.
0.
Similarly, here also see, here also this angle is 90 degree, right? Theta is still 90. So again, flux for this surface will also be equal to 0, means flux due to the circular surface will be equal to 0. That we can see, right? Okay. What about this surface, which is curved surface? If you see the normal to this curved surface, don't you think it will be right, pointing towards right? What do you say?
Yes, sir.
What will be the value of theta here? Theta will be equal to 0 degree. Am I
0.
correct? है ना? So the
Yes.
only flux, that net flux will be equal to flux due to the curved surface, you can say. And that curved surface flux will be equal to electric field multiplied by area of the curved surface. Electric field multiplied by area of the curved surface. Who will tell me what is the area of curved surface?
2 pi RL.
Very good. That is equal to 2 pi r multiplied by h. H is this L. So this is the curved surface area. This will be the value of flux, 2 pi RL multiplied by E. Did you understand?
Yes, sir.
हरी आप नोट करो इसको. कर लिया नोट, आगे बात करें.
Yes, sir.
ठीक है. एक और क्वेश्चन मुझे बता सकते हो क्या? इफ दिस इज अ हेमिस्फीयर, this is a hemisphere. I think you know hemisphere. And the radius of this hemisphere is r. This is the radius of this hemisphere. And electric field lines are passing through like this. This is the field lines which is passing through this hemisphere. Okay? And the electric field is E. What will be the value of flux through this hemisphere? What will be the value of flux through the hemisphere? ठीक है, चलो मिलके करते हैं. तो देखिए, मुझे एक बात बताइए, ये हेमिस्फीयर के थ्रू फ्लक्स कितना है? मुझे एक बात बताओ, आप इस डायग्राम को देखो एंड जस्ट टेल मी द नंबर ऑफ फील्ड लाइंस व्हिच इज पासिंग थ्रू दिस सर्कुलर बेस. If you can see the base of this hemisphere, it is circle, right? Is it circle or not, बेटा? हेमिस्फीयर का जो बेस होगा ना,
Yes, sir.
हेमिस्फीयर समझते हो ना? The base of this hemisphere is
Yes, sir.
obviously a circle. So can you tell me कि the number of field lines passing through this base, is it same to the number of field lines passing through this curved part? इस
Yes,
वाले
sir.
पार्ट से मान लो इसको मैं एक सरफेस कह लूं और इसको मैं दूसरा सरफेस कह लेता हूं, तो द फील्ड लाइंस पासिंग थ्रू 1 and 2 इज सेम और नॉट? टेल मी यस और नो.
Yes, sir.
ठीक है, इसका मतलब कैन आई से दैट कि फ्लक्स थ्रू हेमिस्फीयर flux through hemisphere is equal to flux through circular base.
Yes, sir.
ठीक है, हेमिस्फीयर का जो फ्लक्स होगा वो जितना इस से फ्लक्स निकल रहा है उसके बराबर होगा. तो इससे कितना फ्लक्स निकल रहा है? व्हाट इज द वैल्यू ऑफ फ्लक्स? तो इस बेस पे इफ आई टेक द डायरेक्शन ऑफ नॉर्मल ऑन दिस, ठीक है, दिस इज द डायरेक्शन ऑफ इलेक्ट्रिक फील्ड, तो कैन आई राइट फ्लक्स इज इक्वल टू इलेक्ट्रिक फील्ड मल्टीप्लाइड बाय एरिया मल्टीप्लाइड बाय cos 0 degree. See
Yes,
if you
sir.
are convinced. So flux will be equal to electric field area of the base, and base is of what shape? It is of circular shape. So area of the circle is pi r square and cos 0 is 1. So this will be the value of the flux through the hemisphere. Did you understand? Flux through the hemisphere will be same as that of the flux through the circular base. The value of flux through the base and hemisphere will be same. So we have calculated what? We have just calculated the flux through the base, and obviously this flux will be exactly equal to the flux through the hemisphere. I hope you all have understood this.
Yes, sir.
Note करो इसको. ठीक है, तो आज इतना ही. Rest we will discuss in the next class.
Thank you, sir.
ठीक है, welcome.